Hello students, my name is Rituparnade. I am an assistant professor of Department of Civil Engineering in Swami Vivekananda Institute of Science and Technology. Today we are going to start Soil Mechanics 2, which has a subject code of CEPC 504. In this subject we are going to learn the first chapter, that is soil compaction. So before starting compaction, let us go through its definition and its significance. So what do you mean by compaction? Compaction is basically a process by which soil particles are artificially rearranged and packed together into a closer state of contact by mechanical means in order to decrease the porosity or void ratio of the soil. Thus, in a result, increase its dry density. So, as you have gone through the previous soil mechanics part, that by increasing the density of the soil, the bearing capacity of the soil or the unit weight of the soil increases. So what is the result of compaction? Compaction is carried out in any type of soil so as to increase its dry density, which in other term increases the capacity of the soil. So how this compaction is carried out? Compaction can be carried out either by rolling or by tamping or by vibration, depending upon the type of the soil. So how this compaction takes place? As we all know that each and every property of the soil has to be determined by performing any particular test. So here the compaction density or the density which can be achieved through compaction can also be found out for performing some particular test in lab. So what are those tests? These tests are stated as standard or modified Proctor test, Harvard miniature compaction test, Abbott compaction test, Jodhpur mini compactor test. Among this test, we will study only the first two tests, that is standard Proctor test and modified Proctor test. These two tests are of utmost important for finding out the dry density of the soil. Before starting the experiment or before describing about the test, let us go through the factors which is mainly governing the compaction or which is mainly governing the density. So main factor which governs the density is water. How water is affecting? Suppose if you take a very simple example for building any kind of construction, you will see for filling material some kind of white sands are being used. So this white sands are used as filling material. After placing the white sand, you can easily see that this white sands are being tampered with a tamping rod. Along with the tamping, water are being sprinkled on the top of the white sand. Why the water is sprinkled on top of the white sand? This water act as a lubricant. This water act as a lubricant between two soil particles, which helps the soil to come in a closer contact with each other. The main focus of compaction is to release the air which is present in the voids of the soil. As you have studied in the previous soil mechanics that the soil consists of three phases, that is solid, air and water. The main propaganda of compaction is to release all the air present in the void so that the soil particle can come in a closer contact and in a way increase the density, or they can be compacted together so as to take more amount of load. So water mainly act as an agent or a lubricant and help the soil particle to make a rearrangement amongst themselves. So when we are going to study about the experimental part, water plays an important factor in this test. So let us move on to the standard Proctor test. Mainly, standard Proctor test was developed by R.R. Proctor in the year 1933 for the construction of Earthfield Dam in the state of California. What are the equipments that are being used for standard Proctor test? The test equipment consists of cylindrical metal mold having an internal diameter of 10.15 cm and internal effective height of 11.7 cm and a capacity of 0.945 liter. It also consists of a detachable base plate, a collar of 5 cm in effective height, a rammer having weight 2.5 kg which falls through a height of 30.5 cm. The test consists in compacting the soil at various water content in the mold having 3 equal layers, each layer being given 25 blows with the help of a rammer which is dropped from a height of 11.7 centimeter. The dry density obtained in each test is determined by knowing the mass of the compacted soil and its water content. The compactive energy used for this test is 595 kg per meter cube. So let us go through the test equipments. What I have described in the test equipment, that is the cylindrical metallic mold. So this is the cylindrical mold in which the soils are being compacted in 3 layers. Each layer will be given 25 blows with the help of this hammer, and it consists of a collar which has a height of 60 millimeter. So this is the collar, this is the cylinder, and this is the rammer. So how this test proceeds, I will describe in the next section. Normally about 3 kg of air-dried and pulverized soil passing through 4.75 millimeter sieve is mixed thoroughly with small quantity of water. The mixture is covered with wet cloth and left for a maturing time of about 5 to 30 minutes. These are being different for different kind of soils, and this maturing time is mainly permitted for proper water absorption. The initial water content that can be mixed with the soil may be taken as 4% for coarse grained soil and 10% for fine grained soil. What happens in the test is that the empty mold attached to the base plate is weighted without collar. This collar is being neglected, only this part is weighted. The collar is then attached with the mold. The mixed and matured soil is placed in the mold and compacted by giving 25 number of blows with the help of a dammer which is uniformly distributed over the surface such that the compacted height of the soil is about 1/3 of the height of the mold. Before putting the second installment of the soil, the top of the first compacted layer is scratched with the help of any sharp edge. The second and the third layers are similarly compacted. Each layer is being given 25 blows. The last compacted layer should be projected not more than 6 mm into the collar. The collar is removed and the excess soil is trimmed off to make it level with the top of the mold. The weight of the mold, the base plate and the compacted soil is taken. A representative sample is taken from the center of the compacted specimen and kept for water content determination. You have already gone through the previous soil mechanics unit that how to calculate the water content. As you already know, the water content can be calculated from a simple laboratory experiment, that is oven dry method, or it can be calculated in a quickest way by calcium carbide method. But for the accuracy of the result of finding out the water content, we mainly go for the oven dried method, where a sample is been taken, weighted and then placed in a oven for 24 hours. After 24 hours the soil is again been weighted, and how the water content is determined? The weight of water which is obtained by subtracting the soil before placing in the oven and after placement of the oven, by getting the weight of the water divided by the weight of the dry soil multiplying by 100. Then we can easily achieve what is the value of the water content. So from that procedure, water content can be determined. The bulk density and the corresponding dry density for the compacted soil can be given from the following relation. So this is the relationship between the dry density and the bulk density. This relationship you have already studied in the previous soil mechanics 1, where the density of the soil is given by mass per unit volume. This mass is represented in gram. M is the mass of the weight compacted specimen, which is given in gram. V is the volume of the mold, which is 945 milliliter. Gamma T is the dry density of the soil, and W is the water content of the soil, which is given in a ratio. Then what happens consecutively? The compacted soil is taken out of the mold, then it is broken into with hands and remixed with water content approximately 2 to 4%. After allowing for the maturing time, the soil is compacted in the mold in 3 equal layers, and the corresponding dry density and water content are determined. The test is repeated on soil samples with increasing water content, and corresponding dry density is obtained. And this relationship between water content and dry density can be established from a curve. This is a curve of dry density and water content. Okay. So, compaction curve is plotted between the water content in the abscissa and corresponding dry density in the ordinate. So, how this curve is being plotted? Suppose we take a certain amount of water content and corresponding to the water content we obtain a dry density. So, suppose we get a point over here. Then again we take another water content and then we get the corresponding dry density over here. So after getting those points, we join the lines to get the curve. So as we can see in the curve, the dry density goes on increasing as the water content increases till a maximum point is reached. You can easily see a point where it can be seen that after increasing the water content, the dry density goes on decreasing. So after we see that after a certain amount of water content, the dry density goes on decreasing. So the maximum dry density obtained from this curve is given as gamma T max, and the corresponding water content for the maximum density is known as optimum moisture content. So optimum moisture content is that water content beyond which the density of the soil decreases. Thus, whenever we are going to perform any compaction test, it must be kept in mind that the water content must not increase the value of OMC or optimum moisture content. If the value of the water increases from OMC, then what will happen? The result will be in decreasing the dry density of the soil. So from here we can easily find out what will be the maximum dry density for the particular type of soil. And the left hand side of the curve, as we can see, it is known as the dry side of optimum. That is when the soil is approximately dry. And here, as we can see that the water content keeps on increasing, so this portion is known as wet side of optimum. Clear? Okay, then we are shifting to the 0-year void line. As we can see in the graph that a line going parallel to the wet side of optimum curve. This line is known as 0-year void line. So, what is 0-year void line? This line mainly shows the water content and dry density relationship for any kind of compacted soil containing a constant percentage of air void. So this is also known as air void line. And how this relationship can be established? This relationship can be established from this formula where rho d equals to 1 minus Na into G into rho W divided by 1 plus Wg, where Na is the percentage air void, W is the water content of the compacted soil, rho d is the dry density corresponding to the water content, G is the specific gravity, and rho W is the density of the water, which is taken as 1 gram per cc. The theoretical maximum compaction for any given water content corresponds to 0-year void condition, as we know that maximum compaction can be achieved when all the air present in the void of the soil is being eliminated. So for this reason we are considering Na as 0. So whenever maximum compaction is achieved, we will have number of air voids as 0. So the air void percent will be 0, and putting the value of Na here 0, we will get the corresponding dry density as G rho W divided by 1 plus Wg. So this line showing the dry density as a function of water content for the soil containing no air void. Hence, this line is known as 0-year void line. Since no air is present here, so this line is known as 0-year void line. Alternatively, we can also use this equation also, where rho t is given by G rho W by 1 plus Wg by S. This relationships you have already studied in the previous soil mechanics class. So where S is the degree of saturation. So when we will put degree of saturation as 100%, we can easily achieve this formula. That means putting S equals to 100, we can again achieve the previous formula. Hence, the air void line or degree of saturation line, when drawn across a compaction curve, it gives a direct indication about the percentage of air void or the degree of saturation existing at different points in the curve. So from this curve, what we are getting? We are getting the values of optimum moisture content along with dry density of the soil, maximum dry density of the soil, along with the 0-year void line. So from the 0-year void line, we can easily get the either we can get the percentage of air void or the degree of saturation which exists on different points on the curve. So this is about the preliminary phase of compaction. In the next topic, we will study about the factors which affects compaction and other different type of test, which is modified Proctor test, along with the changes in the soil structure while compaction takes place, and some numericals which is related to compaction. So thank you everyone.